Thank you for joining my keynote regarding CleanTech in the Tech Days digital conference on the subject of our H2 harvester system. I hope you are doing fine. My name is Marcel Vroom, co-founder and co-inventor of the H2 harvester. I'm working at NPK, an international industrial design agency from Leiden, the Netherlands, at design and business development. The initial idea we had was made clear with this iconic image, of which some people say it comes from the science fiction movie Interstellar, with large machines moving autonomous across the fields. At least it helped us to get enough attention in a competition organized by the Dutch government called Solar Power in Agricultural Areas, and finally win the competition. That was end of 2017. The topic of the competition still is very relevant today, where we see the need for more sustainable energy sources by developing large wind farms at sea and solar farms on roofs and in the countryside. But do we want more solar energy on farmers' land? As this conflicts with our food production with a growing number of people. And if we harvest solar energy on farmers' land, where do we connect it to? As there is no grid connection available at this size and quantity, plus all the generated energy will lead to network congestions. H2 harvester is a solution for circular agriculture, a solution for generating clean energy by using abundant agricultural land and converting it into hydrogen towards climate neutral farms and more sustainable agriculture. Generating sustainable energy is combined with preserving productivity and biodiversity. One of the results of our research is shown in this image. We found the sweet spot. Every circle concerns a very urgent topic related to sustainable energy transitions, the earning model for the agricultural sector, and also preserving soil health and biodiversity. So to summarize, combinations of two current issues in the sustainability task for agricultural businesses, like revenue model, energy transitions, and soil health, they generate large conflicting interests. But the combined combination of the three issues does lead to a feasible scenario, the sweet spot, with the help of H2 harvester, a mobile solar panel system, local storage, and local application of hydrogen. To elaborate a little bit more about our sweet spot with H2 harvester, I show you our energy model for circular agriculture, based on two important points: local for local, and scale by scale. This means we do not want hydrogen to be harvested at the Sahara and then put into hydrogen, transported by ships to harbors, and from there on being pushed forward into the mainland. No, we want the local companies like farmers to produce sustainable energy by solar and wind power, and of course using the movable solar wagons we provide, so that locally the energy can be provided to electrolyzers that are located on the farmer's land. The farmers can produce the hydrogen for several reasons: to use for their own machines, like tractors, but also supply it to companies that are related to their business. So, like manufacturers of milk, or the milk compression companies that make milk powder, or that provide food for the cows and the chickens. That's all very intense use of electricity and energy to make these next products in the farmer's circle. At last, we can provide the hydrogen to other sectors, to other companies, like public transport companies, or even the gas stations or fuel stations that are located nearby the farmer's land. When hydrogen being made by electrolyzers, there is a lot of heat being produced. This heat is about 30% of the energy put into the electrolyzer. Normally, this heat is being wasted in the air, but we can use this heat very good and profitable at the farmer's area. He can dry the grass, he can dry the tulips bulbs, he can dry potatoes, and so preserve also the quality of grass, potatoes, and tulips. Let's dive a little bit more deep in the H2 Harvester mobile solar panels for arable and dairy farming. As mentioned before, and maybe you've seen it, we have a multiple use of agricultural land. And only 10% of the agricultural land is temporarily covered. The effect on the yield is limited by this short-term coverage. And also the shade is evenly distributed, so there's no harm for the crops and the growth. There's a mild coverage, which even has a positive effect on the growth of grains and grasses. And because the farmers can earn more money from the same arable area, they have an incentive for biodiversity and better soil quality. If we look at a new business model for farmers, you see that sun is an extra crop. Hydrogen is dark green from our own country. The hydrogen comes from sustainable sources, mainly from solar energy, and the electricity that is being converted into hydrogen does not come from the electricity network. So locally produced sustainable energy and heat. With local buffering, we can have seasonal storage of the same sustainable energy. So in wintertime, we can use the energy harvested in the summer. Energy, heat, and raw materials cycle in a local and regional energy system. And there are no restrictions due to the possible net congestions which we discussed earlier. When designing and engineering the mobile solar panel system of H2 Harvester, we looked at an excellent landscape integration. Therefore, the height is at max 1.6 meter, so you can look over it from a distance and nearby. The ground clearance is up to 1 meter. Normal agricultural activities can remain possible. The ground can be easily cleared for agriculture and other processes because the solar wagons can be moved away. Local mechanization systems and other terminal processes can be fed into a smart farmer grid, which we also designed. More in detail, you see a modular system produced industrially, is flexible and scalable. Producing it industrially takes care of fast installation at the site of use. The system is autonomously driving on farmland and across ditches. It's an all-wheel drive system with large wheels and ground clearance, as mentioned before. On the module, 24 solar panels are mounted, which has a length together of 12 meters. 4 modules are mounted together to have a 50-meter system and 168 panels together. I hope you understand that we do not design and engineering the electrolyzers themselves, but we do understand what to do with the hydrogen on the farm. The electrolyzers are being supplied in a 20 or 40-foot container and is placed on the yard. The hydrogen is buffered below ground level. The yield per hectare is 200,000 kilowatt hours per year, which resembles 4,000 kilograms of hydrogen per year per hectare. Heat production, which I said is almost 30% of the energy put in, can be used for drying and fermentation processes. And in case you want more detailed information, please contact us on the website or by mail info@h2harvester.nl. Thank you for your attention.
Hello everybody, and thank you for having me. I'm Linda Splitt and I'm working in the business development at Cloud and Heat Technologies. I'm sorry that I'm not using the stylish background of the tech days, but it seems that my hair is too bright and I couldn't figure it out in time for this recording, and I didn't want it to look like I'm from the movie Tron. But today I will give you a little insight about the possibilities of making AI more sustainable and secure. First, I will tell you a little bit about Cloud and Heat, and then I will describe on a real project which challenges AI companies might face nowadays. And then I will illustrate what we did with and for our partners to provide a holistic solution. Afterwards, you can ask me some questions if you like. So, who are Cloud and Heat? Cloud and Heat provides several services around energy efficient and secure digital infrastructures. So, we plan, design, build, and operate data center solutions. The company was founded in 2011, and the idea was to reuse the emitted heat of the servers. Nowadays, we are a full-stack data center provider with many sites, especially in Dresden and Frankfurt. We are using open source software for the operation of our data centers. So, for example, the virtualization of our servers is based on OpenStack. And Cloud and Heat is involved in various projects like Gaia-Shi, the so-called gold standard in cloud services, and the project Auditor, which is aimed at designing and implementing a data protection certification of cloud services. Now I will give you a little overview about our real-world use case with our partner AI4BD. So AI4BD developed a method called Cognitive Business Robotics, or CBR in short. To give you an example, a company receives a handwritten order via fax, and yes, they still exist in some businesses. So traditionally, now someone has to enter the information into a computer. Now the CBR can take care of this job for you. AI4BD is a formerly infrastructure as a service user of our infrastructure, and they realized that the core competency is not to administrate the infrastructure, but to provide AI services. So after some short experiments with their own Kubernetes cluster, they asked us to help. So for some companies, it's not so simple to manage these Kubernetes services. So you have your application in a container, and then you have to wire them, you have to provide storage to them, and you have to provide the containers among your infrastructure. So if your software grows, it's getting more and more complex. So it might be a good idea to have a partner for this. Also, AI4BD has some high requirements in data security and privacy. So the data storage and processing should happen exclusively in Germany. Now we know a little bit about the framework of this use case. So beside how to train an AI and to deal with codes of conduct and the ethics, etc., there are some challenges for AI companies. For example, you have a lack of compute power. AI, specifically the machine learning and deep learning techniques, require a huge amount of calculations to be made very quickly. So this means they use a lot of processing power. Also, they have a demand for high flexibility and scalable solutions. Of course, they also want to reduce the dependency on the vendor. And sustainability, it's getting more and more important nowadays. The second point is that they have a lack of people power. So, as you know, IT experts are rare, and companies want to focus on their AI development and not operating everything by themselves. So, the third point is that they have to build trust. So, in the algorithms and in the systems they are running on. So, this includes the data centers as well. So, you have to increase the security measurements for their sensitive data. So how do we help? First of all, of course, we have the compute power. We are a full-stack provider, and we can install and manage your specific servers, which suits the needs of the different applications the best. So we can do this remote as well as on-premise. And we aim to build and operate our digital infrastructures as sustainably as possible. We also want to be as flexible as possible, and this means point one regarding the installed and available hardware, and point two regarding the whole digital infrastructure. So we are talking and developing the platforms together with our partners to understand their needs. And if possible, we help with our IT team and with their knowledge to challenge together the lack of people, and so that our clients and partners really can focus on their development. Last but not least, we have to fulfill the high data security requirements. The services are provided from a location in Germany, and we have the ISO 24001 certificate. Okay, so let's have a closer look how we are achieving this. So we live green IT. It's a founding idea and also the personal motivation of our staff. So in the middle you see the cute little water-cooled data center container. So there are various ways to increase the energy efficiency of a data center. We focus on direct hot water cooling because through this we are able to use the waste heat of the servers and to heat the buildings, or to use this otherwise. And we can also eliminate the onboard fans, which leads to a reduction in power consumption as well. Of course, we want to use renewable energy resources, and for our big vision, we are also working on software-based energy optimization. So, beside operating from Germany, having different certificates and controlling the full stack, including hardware and software, we developed a security-hardened OpenStack distribution called SecuStack to further enhance the data security. So, SecuStack is a virtualization to share physical hardware among users. So the reasons for this is to increase cost and energy efficiency. And also, if traditional means of separation might not be enough, you have two options. So option one is you can build a private cloud where the hardware is used exclusively by one tenant. Or option B, the path where we are investing in, to harden the virtualized infrastructure and offer verifiable tenant separation. So SecuStack is a joint venture of Cloud and Heat and Secunet, a large German security company. So we had a strong partner to really increase these security measurements. And together we developed the same cloud platform, which builds upon the OpenStack cloud operating system. So the tenant separation, as you can see, is achieved via volume encryption, network traffic encryption, and perspectively hardware support like Intel SGX. VPN as a service and bring your own key further enhance the tenant's data privacy. So with these four functions, you can really put the sensitive data in the cloud. So now I want to show you or give you a little better understanding about the managed Kubernetes cluster architecture. So here you have an overview. If you might not know what Kubernetes is. So this is a container orchestration platform, and you can use this to simplify your management of services and machines on a cluster. For AI4BD, the idea was that they have a software stack that includes distributed MongoDB, TensorFlow, and some web services. So the applications of AI4BD were already containerized, so Kubernetes was the ideal platform to further work on. We started with AI4BD with a small prototype. Now we have a production-ready Kubernetes distribution, and we assembled a well-tested and better-proven software and made modifications and additions wherever necessary. For example, our technicians developed external load balancer and made it available as a Kubernetes resource. The cluster is currently deployed on either OpenStack or SecuStack, but bare metal installations are also syncable. The cluster is unreachable by default from the outside because it resides in a private network. The access is possible via gateways, and the gateways also act as a load balancer for the Kubernetes control plane. The cluster is highly available and resilient to outages. As you can see, we have a multi-master setup, so there are 3 master nodes. The underlying virtual machines are in different availability zones to also increase this availability. And the storage solution is built with Rook, which spawns a Ceph cluster inside the Kubernetes cluster. And so it's also possible to implement different hardware. So for example, different types of GPUs. So to provide AI4BD with a good flexible solution. And as you can see, we have a Prometheus and Grafana monitoring stack in each cluster. To summarize the advantages, so we have the full package here, which consists of a security-hardened cluster, sustainable hardware infrastructure, 24/7 operations, and custom solutions depending on the different use cases. Well, and that's it for today. Thanks again for having me, and here are my contact details. Do you have any questions?
Hello, I'm Andreas Gallasch, CEO of Software Factory. I'm proud to represent Wilhelm Maus, CEO of Lawrence Water Meters. Wilhelm sends his apologies. The technical requirements made it necessary that Wilhelm worked out the slides and I recorded the sound. I will present a business transformation case of a small-medium enterprise. From a small manufacturing company to an award-winning technology leader for smart metering and Industry 4.0. The presentation I give you today is structured as shown in this slide. First, I give you a short overview of Lawrence, and then I introduce you to the background and the business environment. The solution of the challenges will be the digital and ecological transformation. And at the end, I give you 4 key takeaways how to master from analog and linear to digital and circular. But let's start with Lawrence. Lawrence is a small company with 20 million in revenue and 190 employees about, and they produce about 1 million water meters a year. They are family owned, and they are also a high-tech partner of German-Israeli activity. The company has received several awards for research and development, for resource efficiency and corporate responsibility. Most recently, and I think this is really a key point, Lawrence receives the German Innovation Award for Climate and Environment by the Federal Ministry for the Environment and the Federation of German Industries, the BDI. I would say this is really impressive. Let's come to the background of the business environment. The industry is caught between a price war and outsourcing on the one hand side and market and technological dynamics. To give you an example, on the one hand side, there's a high price pressure above all from Chinese competitors. There's a substitution of brass as main material by plastics. And there's a relocation of numerous competitors to low-wage countries. On the other hand, there's an increasing level of individualization and diverse variance due to a wide range of customer requirements. For example, the multitude of proprietary and open communication systems, or the consumer protection and the hygienic safety measures. So, a real tension in the market. To survive in this market, it is necessary to achieve the objectives on the left-hand side. And this is not easy to achieve. But you need the right, of course, but definitely not easy measures to lead, which then leads you to a holistic strategy. And this strategy is based on smart products and a holistic lifecycle management, an intelligent production, digital services and new business models, and resource efficiency in circular economy. I really do strongly believe, in the end, all parties involved benefit from high-quality products. It is necessary to play the decisive advantages as an economic lever. And these advantages are the accuracy and stability, the networking, and the durability and the recycling. And only quality products are suitable for remanufacturing. This results in lower total cost of ownership, no disposal, less frequent replacement, lowest process cost for the customers. And to be honest, the digital and ecological transformation opens up a complex portfolio of opportunities in the market. And due to the time limits we have here, I can only show it to you, but cannot step into deeper. Let's come to the digital and ecological transformation. To give you a short overview how the holistic implementation of circular economy works. It starts in the left corner of this line 8. And Lawrence supplies sophisticated smart meters to utilities, to municipalities and metering services. It is not possible to tell from the individual meter whether it is new or reused. The utilities, municipalities and metering services install the smart meters in the network and at the end customer. After a maximized service life, the smart meters are replaced and then returned to Lawrence. There are refund models and rental models and other economic models which made it easier for the utilities and the municipalities and the metering services to participate in this circular economy. And to make it really easy for them, Lawrence accepts not only its own meters, but also third-party products, which are disposed of separately and professionally, of course. So you have a never-ending cycle of reused and new products coming in the cycle and going out and then coming back in. This circular economy leads to really complex logistics. And the manufacturing, or better said, the remanufacturing, creates a complexity which is really huge. So it was necessary to bring different skills and capabilities together. Lawrence with product know-how, of course, and also the mechanical engineering capabilities for the assembly lines. ETQ for managing the program and the different projects within the program, and breathing life into the machines and the lines with the PLC programming. And we from Software Factory, with building a production control system and a production line systems, formerly known also as manufacturing execution system in SCADA, and this on top of a digital twin, because this was necessary because of the high demanding requirements coming out of the circular economy. And so we've been able to allow the high variance of the product and also the complexity of the circular economy. So let's summarize how Lawrence did this journey from analog and linear to digital and circular. And as we have seen, the digital transformation and the resource efficiency go hand in hand. So the key takeaways for you should be: Lawrence focused on strength and addressed also the weaknesses. and had always the quality and the customer orientation in focus and versus the cost. It was absolutely necessary to master complexity and so to turn the challenge into competitive advantage. And it was necessary to reduce the process costs and not the wages. Lean, not cheap, was the slogan. And Lorenz found an answer to outsourcing. And quality pays off. Circular economy plays out the advantages of superior products and services. It really adds value and economic benefit to the customer. So thank you very much for your attention. The Lorenz company, in particular Wilhelm Maus, will be pleased to answer your questions. If you have any questions about the logistics concepts and the necessary IT infrastructure, please do not hesitate to contact me. Thank you.